Okay, in mathematics, we come across endless functions which work with all sorts of real numbers. Numbers like 4, 5, pi, root 2, and so on. And then there are a handful of those that restrain themselves to just integers. And I'm going to introduce you to one of them in some sort of a visual way. Our function is called the greatest integer function, or step function as some of you would like to call it. So greatest integer function uses this square brackets around x, and we call it the greatest integer function of x. And what that means is it's the biggest integer less than or equal to x. So what does that mean? Well, let's take a look at some examples. Suppose we want to find the greatest integer function of 14.1. That means that I want to find the biggest integer that's less than this number. We'll notice that 10 is an integer and is less than 14.1, but is it the biggest integer? Because actually 12 and 13 or even 14 are examples of integers that are less than 14.1. What about 15? Well, 15 is definitely not less than 14.1. So that means the greatest integer that is less than or equal to 14.1 has to be 14. Well, if you put in a positive value, what the greatest integer function basically does is it chops off the decimals. So if I ask you to find the greatest integer of 7.389, all you have to do is chop off the decimals, and what's left is 7. That's the answer. What about the greatest integer function of 5? Well, 5 is itself an integer, and 5 is less than or equal to 5. It satisfies the condition, and therefore 5 is the answer. In fact, the greatest integer function of any integer that you put, it will be that integer itself. The greatest integer function does nothing to the integers. It chops off the value for the non-integers, but it does nothing to the integers. Okay, what about negative integers? Well, negative integers are a little bit harder. We're just not that familiar with them as much as we are with the positive numbers. But there's nothing that a number line cannot simplify, as long as we remember this one thing about the number line. Okay, if you have a number line and you move to your right, the numbers get bigger, and if you move to your left, the numbers get smaller. If I'm at 2 and I move right, I get to 3 and 4 and so on. The numbers keep on getting bigger. And if I move left, I get to the numbers 1, 0, -1 and so on. The numbers keep on getting smaller. And this works for negative values just as well. If I'm at -2 and I move to my right, I get to -1, then 0 and then 1. Well, notice that the numbers are getting bigger. -1 is more than -2 and 0 is more than -1. And if I move to my left, I get to -3, which is in fact less than -2. You get the idea. If you're looking for numbers that are less than a particular number, move left on the number line. That's how I remember. Let's do a negative example now. What will be the greatest integer of -3.5? Well, the incorrect answer would be -3, because -3 is not less than -5. Let's draw a number line and check for ourselves. Here's -4, -3, -2, and so on. Here's our -3.5. Moving to the left gives -4 and not -3. So in fact, -4 is the correct answer, not -3. -4 is the integer that's less than or equal to -3.5. Alright, the greatest integer of -10. Well, -10 is itself an integer. And for integers, the greatest integer function does absolutely nothing. So the greatest integer of -10 will still be -10. Okay, so now that we have seen how the function behaves for both the positive and negative values, let's try to draw the graph of the function. Let's try to draw the graph of y equals greatest integer function of x. So let me draw the x-axis and the y-axis. And let me put some points here. Here's 1, 2, 3, 4, and here's 1, 2, 3, 4. This is 0 and -1, -2, -3, and -1, -2, and -3. Okay, let's look at all the integers first, because that's the easiest part. For integers, it gives the same value back. So for 1, it's going to be 1. For 2, it's going to be 2. For 3, it's going to be 3. 0 for 0, -1 for -1, -2 for -2, and so on. Alright, let's plug in some values between 0 and 1. This is my x and this is my y. For 0.1, my output will be 0. For 0.2, it will still be 0. In fact, for all the values up until 0.9 or even 0.99, it will be 0. Except at x equals to 1, where it jumps to 1. So there is a hole here, which means that the graph is discontinuous at x equals to 1. The same is true for the values between 1 and 2. For all the values between 1 and 2, the greatest integer to the left is always 1, except again at x equals to 2. At x equals to 2, the value of the function will be 2. And there's a hole here. In fact, there will be a hole at every integer. For every integer, the graph will be discontinuous. It will keep on jumping at every integer and staying at a constant value between them. Alright, let's take a look at the negative numbers now. Plugging in the values between 0 and minus 1, let's see what we get. For minus 0.1, minus 0.2, minus 0.3, and so on up until minus 1, the greatest integer to the left will always be minus 1. And we can see that the graph jumps at x equals to 0. So we can continue the pattern for negative numbers as well. Let me do it for the values between minus 1 and minus 2. So the greatest integer here to the left will be minus 2. And there will be a hole here. And what we see is this step pattern. And this is the reason why this function is also called step function. And there we have it, the graph of y equals greatest integer function of x.